Hello my dear students, welcome to WBJEE YouTube channel. So today we are going to solve class 12 NCERT, and this is exercise 1.1 and from the chapter relation functions. So let's start. And previously we have solved question number 1 of exercise 1.1. So today we are going to solve question number 2 to 6. So what is question number 2 saying? Show that the relation R in the set of real numbers are defined as R equal to AB such that A is less than equal to B square, is neither reflexive nor symmetric nor transitive. So the relation R is A comma B such that A is less than equal to B square. This is the relation defined, and the relation is defined on whole R, the set of real numbers. So we cannot list the elements of R, so we have to do it in abstract way. So let take A belongs to R, A belongs to R, real numbers. Then is A comma A belongs to relation R. So in order to do that, we have to check A is less than equal to A square or not. And this is a false statement because A is less than equal to A, but A is not less than equal to A square because A is strictly less than A square. Okay, this is why for any A belongs to R real numbers, A comma A does not belongs to relation R. Okay, that is why this relation R is not reflexive. Okay, now to show R is not symmetric, we will give an example, a counter example. Let take A equal to 1 and B equal to 2. So A comma B, that means 1 comma 2 is in R because 1 is less than equal to 4, that is 2 square. Okay, so now check B comma A, that is 2 comma 1 is does not belongs to R because 2 is not less than 1 square, that means 1. So this is false. So we have got a pair 1 comma 2 such that this belongs to R, but 2 comma 1 does not belongs to R. So R is not symmetric. Similarly, to show R is not transitive, again we will find an example. Let A equal to 5, B equal to 4 and C equal to 2. Then A comma B belongs to R, that means 5 is less than 4 square, that is 16, and this is true. And B comma C is also belongs to R because B is 4, 4 is less than equal to 2 square, that means 4. This is also true, but A comma C does not belongs to R because A is 5 and C is 2, that means 2 square, that is 4. 5 is not less than or equal to 4. This is false. So we have got a pair such that A comma B belongs to R and B comma C belongs to R, but A comma C does not belongs to R. That implies that R is not transitive relation. So we have seen that R equal to AB such that A is less than equal to B square. This relation is neither reflexive nor symmetric nor transitive. Okay, please go through once again, you will understand. Then next problem, number 3. The problem is saying check whether the relation R defined in the set 1 to 6 as R equal to AB such that B equal to A plus 1 is reflexive, symmetric or transitive. So we have to check whether this relation is reflexive, symmetric or transitive. So we will write the relation A comma B such that B equal to A plus 1, and we are given that the set A is 1, 2, 3, 4, 5 and 6. We have to take AB from the set A. So here we will list the elements of R. So if we put A equal to 1, then B equal to 2. So 1 comma 2 is there in R, 2 comma 3, 3 comma 4, 4 comma 5 and 5 comma 6. So R is consist of these 5 elements. So check whether R is reflexive, symmetric or transitive. So clearly you can see that 1 comma 1 does not belongs to R, but 1 is belongs to A set. So R is not reflexive. Okay, and you can see that 1 comma 2 belongs to R, but 2 comma 1 does not belong to R. So that implies that R is not symmetric. And to check whether it is transitive or not, see 1 comma 2 is there and 2 comma 3 is there, because we can take 2 as y and this is x and this is z. So x comma y is in R and y comma z is in R, but x comma z does not belongs to R. So that implies that R is not transitive. R is not transitive relation. So clearly for this problem, R is not reflexive, R is not symmetric, R is not transitive. So for this definition of relation, R is nothing. Now problem number 4, show that the relation R in the set of real numbers defined as R equal to A comma B such that A is less than equal to B is reflexive and transitive but not symmetric. So what is the definition of R? R is A comma B such that A is less than equal to B and A or B coming from the set of real numbers. So for all A belongs to R, A is less than equal to A, and this inequality is true because A is actually less than equal to A. So for all A belongs to R, A comma A belongs to the relation. That implies that R is reflexive relation. Reflexive relation. And take A comma B belongs to R. That means A is less than equal to B. If this is true, because this implies that A is not greater than B, so this inequality holds only for A equal to B. If we take A less than strictly less than B, B is not strictly less than A. Okay, so please pause the video here and watch the reasoning once again, because if we take 1 comma 2 belongs to R, that means 1 is less than equal to 2, and here 1 is strictly less than 2, that means 2 is not strictly less than 1, that means 2 comma 1 is not in R. So that is why R is not symmetric. Okay, please watch this reasoning once again, why R is not symmetric. Now let us check A, B, C from R real numbers, and A is less than equal to B and B is less than equal to C. That obviously imply that A is less than equal to C because of the inequality properties of inequality. So this implies that R is transitive relation. Okay, you can easily check. So we have proved that this relation R, defined as A is less than equal to B, is reflexive and transitive but not symmetric. Okay, so next problem 5. Check whether the relation R in the real numbers defined as A comma B such that A is less than B cube is reflexive, symmetric or transitive. So we have to check whether this relation reflexive, symmetric or transitive. So let us write the relation A comma B such that A is less than equal to B cube. Okay, for all A belongs to R from the real numbers, take any A, any number, A is not less than or equal to A cube. This statement is false. So R is not reflexive relation. Now take A comma B belongs to the relation R. That means A is less than B cube. So that does not imply that B is less than A cube, because we can take the similar numbers A equal to 1 and B equal to 2. So 1 is less than 2 cube, that means 8, but 2 is not less than 1 cube, that means 1. So A comma B belongs to R, but B comma A does not belong to R. That means that R is not symmetric. Okay. Now whether it is transitive or not, let A less than B cube and B less than C cube. So that, does this imply that A is less than C cube? So let us take A equal to 9, B equal to 4 and C equal to 2. So you can easily check 9 is less than equal to 4 cube, that means 64, and 4 is less than equal to 2 cube, that is 8, but 9 is not less than equal to 2 cube, that is 8. In fact, it is greater than 8. So A comma B is in R and B comma C is in R. For this case, that is 9 comma 4 is in R and 4 comma 2 is in R, but 9 comma 2 does not belong to R, and for this reason R is not transitive. R is not transitive relation. Okay, so we have seen that for this definition of R, AB such that A less than equal to B cube is not reflexive, symmetric or transitive. Nothing. Okay, so next problem, problem number 6. Show that the relation R in the set 1 2 3 given by R equal to 1 comma 2 2 comma 1 is symmetric but neither reflexive nor transitive. So what is the relation defined, that 1 comma 2 and 2 comma 1? Okay, so and we are given that the set is 1 2 and 3. So we have to show that it is not reflexive and or transitive but symmetric. So you can clearly see that 1 belongs to set A but 1 comma 1 does not belongs to R. So simply that implies that R is not reflexive. Reflexive relation. Okay, so it is transitive or not. Okay, so from here the listing of R, we can say that x equal to 1, y equal to 2, and z equal to 1. So see that x comma y, that means 1 comma 2 is in R, and y comma z, that is 2 comma 1 is in R, but xz, that is 1 comma 1 does not belong to R. So that implies that R is not transitive relation. Okay, now check R is symmetric because 1 2 is there and 2 1 is there. So let us take x equal to 1 and y equal to 2. That means xy, that is 1 comma 2 is in R, and y comma x, that means 2 comma 1 is in R. So R is a symmetric relation. Hence proved. So please pause the video and rewatch, you will understand. So that's it for today. Again we will solve another problems from NCERT textbook. So keep watching videos, and please subscribe to my channel for more videos. Thank you.